Hello everyone, and welcome to another video on test automation. As test automation engineers, it is crucial for us to grasp concepts like abstraction, as they play a significant role in designing efficient and effective test automation solutions. So let's explore what abstraction means in the context of test automation and why it is essential for our work. We'll cover what abstraction is, its importance, its benefits, and also in the end we will explore the layers where abstraction can be used in the architecture with the help of examples. This video also covers the topic on page 29, Introduction to TAA Design, subheading Identify Areas Where Abstraction Can Deliver Benefits in the ISTQB Test Automation Engineer Certification Exam Syllabus. So let's start by understanding what is meant by abstraction. It is the process which involves simplifying complex test scenarios and components into higher level representations. Or in simple words, it is about focusing on essential aspects of testing while hiding unnecessary details, promoting clarity and manageability. In test automation architecture, abstraction layers are used to simplify interactions with the underlying components of the system under test. This abstraction makes test automation more accessible and manageable, even for testers who may not have in-depth technical knowledge of the SUT's internal workings. The question comes in our mind why it is important to apply abstraction in test automation. The simple answer is it plays a crucial role in the work of a test automation engineer by enabling them to design, develop, and maintain efficient and adaptable test automation solutions. By leveraging abstraction effectively, test engineers can streamline their testing processes, enhance test coverage, and deliver high-quality software products. So in other words, it is very important to consider and apply abstraction at different levels of your test automation architecture. It's simple. The more abstraction is used for a test automation architecture, the more flexible it will be with respect to further enhancing, transitioning, or its evolution to new approaches or new technologies. Let's discuss benefits of abstraction in test automation in detail. Well, just like it helps the software development process, abstraction in test automation also offers several benefits that contribute to the effectiveness and efficiency of the testing process. Abstracting test automation frameworks and components from specific tools or technologies reduces dependencies, making it easier to switch or upgrade testing tools without major disruptions to the testing process. Let's say you have a test suite for a web application's login process. With abstraction, instead of directly interacting with UI elements using specific locators, the test suite interacts with the application's functionality at a high level. At some point of time when the technology stack changes, like migrating from AngularJS to React.js, the abstracted test cases remains unaffected, ensuring seamless testing across different technologies without extensive modifications to the test automation framework. The next one is portability. Abstraction enables test scripts and frameworks to be portable across different environments, platforms, and technologies, ensuring consistent test execution and results across diverse testing scenarios. For example, imagine you have a test suite designed to validate the checkout process of an e-commerce website. With abstraction, rather than hard-coding specific URLs or DOM elements, the test suite is designed to work with abstract representation of these elements. This abstraction allows the test suite to be easily ported to test similar checkout processes on different e-commerce platforms or different websites with minimal changes. Another benefit is assurance of vendor neutrality. In the context of test automation, Vendor neutrality refers to the ability of the test automation solution to remain unaffected by changes in the tools or technologies used to implement it. When we talk about abstraction contributing to vendor neutrality, we mean that the test automation artifacts such as test scripts and test frameworks are designed in a way that they are not tightly coupled to any specific vendor's tools or technologies. As an example, let's consider a scenario where a test automation framework abstracts database interactions using a database access layer. This abstraction layer provides a standardized interface for executing database queries and commands. Regardless of the specific database management system being used, for example, maybe MySQL, Postgres, MongoDB. As a result, test scripts can interact with the database using generic methods and SQL statements without needing to be written for each DBMS separately. This vendor neutrality ensures that the test suite can be easily ported to different database platforms, enabling seamless testing across various database technologies without vendor lock-in. Another benefit is maintainability and adaptability of tests. By abstracting test cases, test data, and other test artifacts, maintenance efforts are reduced as changes can be made at a high level of abstraction without affecting the underlying implementation details. The test automation solution remains adaptable to technological advancements, ensuring its relevance and effectiveness over time. Another benefit is that the test automation architecture will be more accessible to non-technicians. Abstraction facilitates better collaboration among team members by providing a clear and standardized way of designing, implementing, and maintaining test automation solutions, leading to increased productivity and alignment. Suppose a software development company is using a behavior-driven development approach for test automation. In BDD, tests are written in a human-readable format using a domain-specific language like Gherkin, which abstracts technical details, focuses on describing system behavior in plain language. For instance, a test scenario in Gherkin might look like this. The test scenario is written using simple descriptive language that anyone familiar with the domain can understand, regardless of their technical background. Non-technical team members, such as business analysts or product managers, can easily contribute to the creation and review of these test scenarios without needing to write code. Tools like Cucumber or SpecFlow can interpret these Gherkin scenarios and execute them as automated tests, bridging the gap between non-technical stakeholders and the test automation processes. This abstraction layer not only improves collaboration but also makes the test automation framework more accessible to individuals with diverse skill set within the organization. Collaborative decision making for abstraction in test automation is essential, or we can say it is actually crucial, because it involves gathering input and insights from various stakeholders, including software developers, quality assurance professionals, and testers. By involving multiple perspectives, it ensures that the level of abstraction chosen aligns with the need and goals of the project as a whole. This collaborative approach helps in making informed decisions that take into account different viewpoints, leading to more effective and successful test automation implementations. As a test automation engineer, we collaborate closely with stakeholders from software development teams, quality assurance professionals, and testing team members. Together, we discuss the level of abstraction needed in different areas of our test automation solution, We also tailor the level of abstraction in our tasks to meet specific project requirements. For example, we identify interfaces that need to be externalized, formally defined, and kept stable throughout the task's lifetime. This ensures consistency and reliability in our automation efforts. One key decision we make is whether to use abstract test definitions or rely solely on test scripts in our test execution layer. We weigh the benefits and drawbacks of each approach to determine the best fit for our project. So for example, suppose we are automating testing for an e-commerce website. Instead of hard coding specific test steps for each test case, we abstract test definitions that describe the intended behavior of the system. For instance, instead of specifying click on add to cart button, we define a test case abstractly as verify the ability to add items to the shopping cart. This abstraction allows for easier maintenance and scalability of test cases as the website evolves. In the same e-commerce website scenario, we abstract the test adoption layer by using a framework like Selenium WebDriver for web-based testing. Rather than directly interacting with web elements using low-level commands, we create higher-level functions or methods that abstract the underlying implementation in details. For example, we might define a function called add to cart that internally handles the complexities of locating and interacting with add to cart button on different web pages. This abstraction simplifies test script maintenance and enhances readability. Continuing with e-commerce website example, we can leverage test generation abstraction by using model-based testing approach. Instead of manually writing test cases, we create abstract models of the website functionality using tools like UML diagrams or domain-specific languages. These models serve as blueprints for automatically generating test cases. For instance, we might define a model that represents the checkout process, including various paths and conditions. Then, using model-based testing tools, we automatically generate test cases that cover different scenarios within the checkout process. This abstraction streamlines test case creation and ensures comprehensive test coverage. Consider a scenario where we are automating testing for a mobile banking application. In this case, we abstract the test execution layer by using a cloud-based testing platform such as AWS Device or Firebase Test Lab. Instead of setting up and maintaining physical devices or emulators locally, we leverage the abstraction provided by these cloud-based services. This abstraction also facilitates parallel execution of tests, leading to faster feedback cycles and improved test coverage. Now, as we have discussed different layers where abstraction can be applied, the test automation engineer need to be aware that there are trade-offs between sophisticated and straightforward implementations of a test automation architecture with respect to overall functionality, maintainability, and expandability. However, it is essential to recognize that the benefits of abstraction come with certain trade-offs. Embracing high level of abstraction often require large initial investments in terms of complex automation architecture, specialized tools, and skill set requirements, and bigger learning curves as well. So these investments may delay the initial break-even point of the automation project as teams invest time and resources into learning new technologies and refining their automation frameworks. Furthermore, increased abstraction may lead to lower performance of the test automation system due to additional layers of abstraction and overhead introduced in the automation process. The more the layers, the more will be the performance overhead. Let's now discuss the return on investment considerations. In simple terms, it's about determining whether the benefits obtained from using abstraction outweigh the costs associated with implementing it. So, this analysis helps organizations make informed decisions about their automation strategies and ensures that the investment made in automation yield positive returns in the long run. While the detailed return on investment considerations are the responsibility of the test automation manager, the test automation engineer plays a crucial role in providing inputs to the ROI analysis. So this include conducting technical evaluations and comparisons of different test automation architectures and approaches. The TAE assesses factors such as timing, cost, efforts, and benefits to inform the decision-making process and ensure alignment with the organizational goals. Okay, here is the summary of key points which we have discussed earlier. Please note that these key points are also important for ISTQB Test Automation Engineer exam as well. The first one is abstraction benefits. So abstraction enhances technology independence, portability of test artifacts, vendor neutrality, and accessibility to non-technicians. Next one is abstraction discussions. We have identified that discussions with stakeholders are very important. So the test automation engineer always have to collaborate with stakeholders to determine the appropriate level of abstraction for different areas of the test automation solution, considering various factors like interface externalization and test generation methods. While abstraction increases flexibility and adaptability to new technologies, it entails large initial investments as well. It requires higher skill requirements and there will be some potential performance trade-offs. The last point is role in ROI analysis. So the test automation engineer contributes to ROI analysis by providing technical evaluations and comparisons of test automation architectures, helping test automation manager to assess timing, cost, efforts, and benefits. And this concludes our topic for today. Thanks for tuning in. Remember to hit the like button, share with your peers, and subscribe to stay updated on similar content. Until we meet again, keep testing with joy.